I'm Tammy Kolda, an applied mathematician, and this is Unlocking LaTeX Graphics. On this channel, I present tutorials on using TikZ and PGF plots. The videos on this channel are based on my book, Unlocking LaTeX Graphics, as well as some bonus materials. Today, I'll show how to draw an ellipse in TikZ, put some points on the ellipse, and draw an elliptical arc. This episode was inspired by a question from a viewer, so I want to say thanks for the recommendation. Let's get started. Here's our document setup. I'm using parskip to avoid paragraph indentations and hyperref to link the author name to this YouTube channel. We only need the main TikZ package today. Here's our starting point for our picture. For visual reference, I put a grid of help lines from -4, -3 to 4, 3. I define a coordinate C at the origin, which will be the center of the ellipse that we're going to draw. So that you can see where it is, I've temporarily put a black dot and label there. I covered naming coordinates in an earlier episode, which I'll link in the show notes. Now for the ellipse itself. The ellipse needs two parameters, the lengths of the two semi-axes. So that we can be flexible, I'm using pgfmathsetmacro to define the two macros corresponding to our parameters. A equals 3.5 and B equals 2. On the next line, the ellipse path operation takes the syntax A and B, where A is the horizontal radius and B is the vertical radius. Because I'm using macros, I have to put the /A and /B inside curly braces. If they were just explicit lengths like 3 and 4, you wouldn't have to put them inside curly braces. Here's the compilation. I'll link my prior episode covering the basics of circles and ellipses in the show notes. Just so it's clear how A and B are used, I thought it might be helpful to just draw some arrows that show you where they come up. So A is the horizontal semi-axis and B is the vertical semi-axis. Now you can see how those lengths translate into the ellipse that you see drawn. Now that we understand the center and the two parameters, let me go ahead and comment out those lines so that we have something clean that we can work on moving forward. Now every ellipse has two foci, so let's label the rightmost one for this ellipse. In order to do that, I first have to calculate this parameter that I'm calling C, which is the square root of a squared minus b squared. I compute that with pgfmathsetmacro and store it in the macro name C. I covered math calculations in an earlier episode, which I'll also link in the show notes. Then I'm going to place a coordinate named F at C, 0. I could have also put it at -C, 0 to get the other focus point. So that you can see it, I indicate it with a dot and the label F below once I compile this. And there you go. Now let's put a point on the ellipse. The points on the ellipse are parameterized by angles running from 0 to 360. For the parametric angle theta, the corresponding point would be at C plus A cosine theta, B sine theta. You may be tempted to calculate out that point using PGF math macros, and you can. I've done it. But there's a shortcut using polar style coordinates that makes it a lot easier. For an ellipse polar style coordinate, we instead write angle colon A and B, giving the two radii. This automatically maps to the point corresponding to that parametric angle. One subtlety is that the parametric angle is not the true angle measured from the center. For this point, I'm using the parametric angle of 76. I've put this into a parameter P so that we can reuse it. I'm also naming the coordinate P, and I'm drawing a dot there with a label P above it. Let's add a second point Q exactly the same way, but add a parametric angle of 144. Now let's try to draw an object that goes from F to P, traces out the arc of the ellipse to Q, and then connects back to F. Let's first draw the line from F to P. So we have that there. Now let's do an arc continuing from P. So we're going to add an elliptical arc in the same line. I'm just going to make a new line before the semicolon. I'm going to paste arc. It runs from the parametric angle /P to the parametric angle /Q using the two radii that define the ellipse. Now it automatically ends at the point Q without me setting that as a explicit finish point. I covered arcs for circles in a prior episode that I'll link in the show notes. To close the region, I add a line back to the start just using the cycle command. And then that closes everything up. Now that the outline is complete, I can fill it in. So I'm going to go here into the path options and add fill is orange and then set the fill opacity to 0.5. There it is. Now you know how to draw ellipses, identify points on the ellipse, trace out an arc of an ellipse, and then put that all together to get a filled object like we show here. I encourage you to play around with moving the center, changing the angles, and so on. I hope you enjoyed today's episode on ellipses and their arcs in TikZ. Elliptical arcs are very similar to circular arcs, but they have 2 radii instead of 1. A big thank you to viewer @call25shah for the question that inspired this episode. I include a link to the overleaf document I created today in the show notes. If you found this helpful or interesting, please click like or subscribe. If you have TikZs or PGF plots questions, please post them in the comments. If you want to learn more, please check out the other videos. I also have a book, Unlocking LaTeX Graphics, available for purchase at major book retailers. Thanks for watching.